So in this video, we're going to talk about different classifications of the engineering design process and also talk about the importance of teamwork within engineering design workflows. So it's probably not too surprising to you that not all design jobs are created equal. And one way that you can kind of differentiate or look at different types of design, which is really what a taxonomy is about. Remember that taxonomy is just a term for organizing things, is to group the design projects based upon what your starting point is. So if you read the definition of adaptive design there, the key thing that you want to take away is if you're only making small adaptations to an existing design, that's going to be classified as an adaptive design. And naturally, if you think about the type of skills that would be required to do that type of design as an engineer, that's really going to be like an entry-level task. So when you get your first engineering job, depending upon where you work, someone might ask you to do an adaptive design to a product as kind of initial tasking. The next kind of stage of design is a development design. In that case, you're still working with an existing design. The only really difference from an adaptive design and a developmental design is kind of how large of adaptations you're making to the product. Ideally, in this case, they're going to be relatively considerable modifications versus an adaptive design are going to be relatively minimal modifications. So since you're making larger scale modifications, you're going to need kind of mid-level engineering skills in that case. Of course, the most complex thing will be if you're designing from scratch, that would be referred to as a new design. And in that case, that's really going to be something that's reserved for senior engineers, not only because of the technical skills that are required, but also in that case, the ingenuity that required is a lot broader, right? You don't have a starting point and you're just tuning one little parameter. You're coming up with something from scratch. Another way that you can kind of classify the different types of engineering design work is not only with respect to the starting point, but also with respect to the level of novelty. And novelty is just a fancy way to say newness. We'll see a little bit later on that it's actually one of the criteria that makes something patentable if you're interested in eventually getting a patent as an engineer. So when someone refers to a design that's an evolutionary change, they're talking about something that's pretty obvious to everyone as the next step in the design process or the natural modifications that you would make. So not necessarily you're going to have anything new here, but you're going to have something that's better. So if you've ever been car shopping and you've ever bought a new car, maybe or you've seen your parents buy a new car or something. I know new cars are really expensive, and oftentimes, like when I first started driving, I was always driving used cars, so this analogy wouldn't make sense. But if you're just aware of what new cars are like, oftentimes, if a car is not completely redesigned and you just go to a new model year, it kind of looks the same on the surface. However, you know that it's not necessarily the same. My dad worked in manufacturing for Ford. He worked on the assembly line for various products, starting with the Thunderbird and eventually the Econoline van. And they would shut down for 2 weeks in July to kind of retool the assembly line, even though if you would look at those cars, unless it was a big redesign, they would kind of look the same. So there's just these slight little subtle modifications that are made in that case in improvements. Another thing would be if you have like a new model of a smartphone, if you're moving from like the Pixel 6 to the Pixel 7, yeah, camera's a little bit better. There's better AI built in terms of the photo editing technology and whatnot, but it's just natural and evolutionary change, right? The Pixel kind of differentiates itself on a value proposition of being able to take really good pictures and to be able to edit those pictures. So naturally, you would expect that the next generation of the phone would do actually that. So innovation, really what you're thinking about is kind of not necessarily moving from here to here, but taking a big jump, a big kind of gap between the new product and the old product. And in that case, you're really thinking about something that's novel. So the example that I gave you there is if 6G capability comes along and that is actually integrated within the radio of a phone versus 5G, that capability from a bandwidth and signal quality point of view and range point of view, ideally would be totally disruptive. The phone would work just incredibly better than the prior phone. However, in that case, even though the performance gap in terms of the new design and the old design is really big, it's obvious that that would happen to an engineer. So it's novel. You get like just incredible performance improvements, but it's just kind of an obvious extension of what you would do next to anyone else. And the reason that I say that is that when you actually think about the latter class of kind of novelty with respect to design, and you think about what an invention actually means, in that case, not only is kind of the performance gap really jumping by quite a bit, but in addition, the way that you got to that performance gap would be non-obvious to someone that's skilled in the art. That's the term that's actually used by the U.S. Patent Bar. And that's why something that's patentable has to be both novel, meaning that it's new, no one's ever done it that way before, but also non-obvious. Now, going back to teamwork in engineering, I think it's obvious to all of you that if you're going to be working in engineering, you're going to be working on teams, particularly as technology becomes more and more complex and if you're trying to drive value that kind of comes from implementing a multidisciplinary solution. So that's one of the cool things about our intro course at SAC versus if you were to take the intro course at a university where it's introduction to engineering of a particular type. You get some opportunity to build teamwork and relationships with individuals that might want to be in different engineering disciplines. Some of you want to be civil engineers, some of you want to be biomedical engineers, and so on. And very common if you're working in a large enterprise that you'll be working on projects where you're actually integrating team members from multiple of those disciplines. So how do you make a good team? And I think these are pretty obvious to everyone, but let's just elaborate on a lot of these. One is you need goals across the team that are accepted by all team members. You got to have everybody on the same page. And really one of the things, like from a management point of view, when you all get to that stage, that can really help ensure that everyone is on the same page is to have an incentive structure that encourages collaboration. So maybe like everyone gets a bonus or everyone gets a raise if certain aspects of the project are met, not necessarily kind of singling someone out and saying, oh, well, you added the most value to this project, you get the raise, everybody else doesn't. So incentive structure really is big to make sure that people work together. In addition, of course, having a culture of openness, respect, and honesty, that just goes without saying. That works beyond a team, just to how you interact with other individuals, just making sure that you have these relationships that you can rely on. In addition, a really, really important point now, when you think about the importance of diversity within engineering teams, that's really one of the ways to fuel innovation. And, whether or not, if you have a team that's not diverse, ideally you're designing for a customer base that is diverse. It's global, ideally, if you really want to make an impact. So there's no way that you can kind of really understand the perspectives of all those diverse individuals unless you have a diverse team. So there's lots of research out there that shows that you're not going to be able to really capitalize upon innovation unless you're really ensuring a sense of diversity within your team. So just as some example problems here, we're going to go back to the classification of design that we talked about with respect to starting points. So these are adaptive designs, development designs, or new designs. So if we go to the questions here, due to slowing sales, a manufacturer of paper shredders will redesign several features within its product, including the aesthetic design, the mechatronics, making more paper go through in a given amount of time and reducing the noise, along with the metal used within the cutting mechanism. So if you think about it, I'm sure you all have seen a paper shredder. We're starting our design based upon the prior generation of paper shredder. And we're just going to swap out a few things. Maybe we're going to 3D print the molding for the actual base differently. It's going to look a little bit different. Maybe we'll make it a different color. We're just going to swap out, maybe by mechatronics there. We're talking about the motors and the drives and these sorts of things. We're just going to use a different motor that's quieter and maybe works a little bit better. In addition, we're just going to swap out the material that we're using for the metal within the cutting mechanism. So let's go back just so everyone can see here. Well, it's definitely not going to be a new design, right? Because if it were a new design, we would be starting something from scratch. So it's going to be either adaptive or development. And really what you have to consider there is what is the scale of modification that someone is making. So you can make an argument here that maybe it's an adaptive design or a development design, I should say. I don't know why I'm tempted to say developmental, but since there are so many different features that are being changed there, I'm going to call that a development design. Second, to address concerns with durability, a manufacturer of phone cases will update its manufacturing process to use a known, more expensive polymer in its existing phone case. So we got a phone case that we make now, maybe it's something like this, and we're going to keep it exactly the same way. We're just going to use a new material that has better durability. So we're starting from an existing design, right? And we're only making one small little modification to the actual material that we're using. So most would agree, I think, that that is an adaptive design, definitely. If you read item bullet number 3 here, a manufacturer of laptops with high-end GPUs, those generate a lot of waste heat. So oftentimes people will operate them on a cooling pad. They notice that a lot of their customers are buying these cooling pads for other manufacturers. So they say, hey, we're going to make one, but they don't make one now. So naturally, that's going to be a case of a new engineering design because you're not starting with an existing product internally. Now, the reason I chose that particular example is, of course, you're going to take motivations from your competitors in the marketplace. However, from your end, it really is a design from scratch. So hopefully that makes sense in terms of just knowing that not all designs are created equal. You can kind of break them into chunks or taxonomize them depending upon the starting point of the design or the level of innovation. And in addition, we talked about how teams are omnipresent in engineering design and the value of diversity and ensuring that those teams kind of really reflect the needs, opinions, and perspective of a global market.